So, let's summarize what we're free to do anytime when we have a right triangle. Up to this point, we really only have two options. We either can use a Pythagorean theorem or we can use trigonometric ratios. The question is, how do we know when not to use the Pythagorean theorem and switch to trigonometric ratios instead? That is nearly the first step of your problem solving that involves right triangles, and therefore is very important to be clear on what produces the work with Pythagorean theorem and what means you need to involve trigonometric ratios. To answer this question, simply notice that when we work with Pythagorean theorem, we use a rule leg squared plus leg squared equals hypotenuse squared, which means that there is no conversation about acute angles. No matter what the measure of one or the other acute angle is, it doesn't affect the results of Pythagorean theorem. On the other hand, trigonometric ratios are set up depending on which of the acute angles is present. So the answer is simple. If your problem with the right triangle involves an acute angle, chances are extremely high that you need to use trigonometric ratios. And vice versa. If the angle, acute angle that is not given, either as a variable or as a value, then you will be using Pythagorean theorem. So, let's see how you understood this idea. I'm going to present you with a number of exercises which you are not solving, but observing. Observing for the information that allows you to decide whether we should use Pythagorean theorem or trigonometric ratios. Before you answer these questions, I will ask you to pause the video and on the paper, reflect what your answer would be. Use Pythagorean or use trigonometry for each of these examples. Ready? Let's go. Pause your video. Okay, let's compare the results, and please notice that you were supposed to explain your reasoning. In the first example, you were supposed to use Pythagorean theorem, and the reason for that is that you do not have any information about your acute angles. All information is either about two known sides or about one unknown value of a side. Question number 2, you were supposed to use trigonometry. The reason for that is the presence of acute angle in your right triangle. Question number 3, you were supposed to use trigonometry. The reason for that is again the presence of an acute angle. Number 4, you were supposed to use trigonometry. Why? Notice the symbol of unknown angle. If an acute angle is present, whether as a value or as an unknown element, the problem will involve trigonometric ratios. Number 5, trigonometry. Acute angle is involved. Number 6, this question should not be solved either with Pythagorean theorem nor with trigonometric ratios. Why? Because I've never told you that this triangle is a right triangle, so there is no question which of these rules would be used. In fact, since I didn't specify this triangle is a right triangle, you only will be able to find the range of possible numbers for the third side. That is, if you studied it. The answer for this range is all the values between 1 and 7, not including 1 and 7 themselves. However, if I did tell you that this is a right triangle, then you are dealing with the most famous 3, 4, and this would have to be 5 kind of a triangle. In that case, you would be looking for the missing value by using Pythagorean theorem.